For today's demonstration, we are going to be running the agent in what we call detect mode. So we'll be allowing the attack through to wreak havoc upon the system. That way we can actually demonstrate and show some of our response capabilities. Now, normally in production, you'd be running the product in protect mode in order to actually have the agent respond to alerts automatically as they're detected. So in this case, something happens, the agent will automatically kill or quarantine said file. But for today, we're going to be running it in detect mode. So without further ado, let's jump into our Windows 10 workstation here. So first things first, on the right-hand side, you're going to see that we just have some, typical documents and pictures. They're not encrypted. They're all in plain text, as we can see, looking perfectly fine. On the left-hand side, I have my email cracked open, and it looks like I've got an email with a security bulletin in it that I want to take a closer look at. And in it looks like there's an attachment, and they're telling me, hey, don't worry, it's safe. So I'm just going to go ahead and crack it open. And immediately, you're going to notice that the agent is actually picking up on something in this document. And if we jump back into the console, and we take a look at our unresolved alerts, or in this case, let me filter my unresolved alerts, we can see here that we do have a detection related to the file. Now, I'm going to give it a second here, and we'll come back to this alert page. But if we hop back into the virtual machine, we should actually see the Word document disappear when the payload actually loads onto the system. It will go ahead and kill that, and then we should start seeing my files and my pictures getting encrypted. So here we can see they're getting encrypted. We can see the .crab extension. We can also see the lovely ransom note that gets left in every single directory, which is graciously telling us how to pay our attacker. So in this case, thankfully we don't need to do that, and I'll show you why. So if we jump back into the management console here, first thing you're going to see is you're going to see some what I like to call the basic data up at the top. So we're going to see maybe timestamps related to the attack, who was logged in, maybe the user that opened the file. We're going to see file path information, the hash of the file, all that good stuff. The other thing we're going to see is some basic data about the endpoint at the bottom here. So maybe what policy it's under, maybe the OS it was running, the IP address it had, so on and so forth. And if needed, we can actually click on the endpoint and perform additional actions like network isolation and things like that if needed. On the right-hand side, here, we can actually take a closer look at some of the reasons why the agent's actually detecting this document. So to be more exact, we're not only detecting the document, but the behavior, the entire storyline that stemmed from opening the document. So here I can see some indicators that looks like I'm dealing with ransomware. I can see some persistence mechanisms were likely dropped in place, so on and so forth. And all of our indicators are mapped to MITRE ATT&CK framework indicators. So if needed, you can actually click on these indicators and it will give you more information about that tactic or technique. In this case, though, I actually want to get a closer look. So I'm going to go ahead and click the Explore tab here. And what this is going to do is it's actually going to visualize the attack storyline that occurred on that endpoint. So here we can see the moment I open the Word document, so I can see the actual document in question, opening winword.exe. And I can already see that something looks a little suspicious. Normally, opening a Word document shouldn't lead to PowerShell triggering off, or at least it's a little suspicious. And if I take a closer look at the PowerShell command, I can actually see that it's a lovely base64 encoded command. So, okay, getting even more suspicious. Now, normally we would have killed it right here because it's definitely not good in this case. But if I scroll down a little bit, the other thing that we'll see is some other useful information like, yeah, other processes spawned, files might have dropped. But in this case, I might be a little bit more interested in the IP address information to the command and control server that this might be talking to. So I might want to do a little research on these addresses, maybe the ports being used, things like that. Now in this case, since we've seen the endpoint, we know what state it's in, we obviously know it's bad. But if we dive a little bit closer, we can see some of the other things that the attack may have done to the system. So in this case, I can see a scheduled task was put in as a persistence mechanism for the attack. I can see the attack going after my shadow copies. So it's actually telling BSS admin to delete all my snapshots there. And I can go in and actually see the ransomware, and the ransomware is actually going ahead and encrypting all the files. It's dropping, its text files to tell me how to pay them and all that. So we can see every step, every event that this storyline, that attack takes. And one really great thing that we can do with that information, and that the agent can actually do, whether it has a network connection or not, based on your policy, is we can actually respond to the attack. Now, as I mentioned earlier, when you're in protect mode, the agent can do these responses automatically based on the policy that you set for the agent. But in this case, since we let it through and we're just running in detect only mode, we're going to go ahead and run these manually. So what we're going to do is we're going to kill any of the related processes that were part of this attack storyline. We're going to quarantine any files that may have been a part of the attack. So, for instance, the Word document actually spawned the attack. If anything else was dropped and executed as part of the attack, that would be quarantined as well. Remediation, this will actually go through and revert any changes made to the system. So if registry keys were dropped into place, the scheduled task that we saw that was dropped in there for persistence, any other files like those text files with the payment instructions, those will get removed. And last but not least, we'll go ahead and roll back any data that was deleted from the system, that was damaged, or in this case, that was encrypted. So I'm going to go ahead and mark this as a true positive because we know that it's a ransomware attack. I'm going to go ahead and click apply. Now, in a couple seconds, it could take anywhere from 1 to 30 seconds for this command to hit, depending on where the agent is at and its heartbeat back to the console. But once it does, it'll retrieve the commands that it needs to run, and we should see it actually delete the text files here. So boom, just disappeared, and we'll also start seeing it recover any of the files or data that was encrypted as part of the attack. So it should just take a sec, and there it goes. And yeah, essentially with that, we have a clean system again. And now what I'm going to do is I'm just going to go back to my alert. And since everything looks good, I'm going to go ahead and mark that as resolved and carry on with my day.